Okay, my friends, we'll get started here. So everybody has notes in front of them then, is that right? So like I said, I don't think we'll finish this here, but again, a couple of reminders for you guys about the Chapter 3 test. Let's just remember that if you need to finish that, make sure you make good on your arrangements, and then if you're going to make corrections to anything, let's have them in by Christmas break. So, all right, my friends, let's get rolling here, guys. Today's title starts Chapter 4. It's titled Nth Roots and Rational Expressions here. Anybody want to volunteer to read my essential question at all? Okay, so how can you use a rational exponent to represent a power involving a radical? Okay, so there's some kind of big words in here. This word rational simply going to mean how can you use fraction form of an exponent to represent a power involving a radical? A radical is simply a sign that's pretty cool. Looks like this. Okay, looks kind of like a square root sign where we would put n up here, and we'll talk more about this. But we're going to start looking how radicals are written with fractional exponents today. So goals to accomplish today are the following. We need to find the nth roots of numbers. Okay, we'll talk about what that means. We're going to evaluate some expressions with rational roots. Okay, that's not too difficult to do. And then we'll look at solving some equations using nth roots. All right. I think you're going to like this chapter here. It's a big change from what we've been doing. We've been looking at a lot of graphs of polynomials and properties of polynomials. I think you're going to find out that there's a lot more evaluating of stuff and more definitive answers here that you can feel good about. So let's get rolling with vocabulary today. Nth root of a. It says in general, for an integer n greater than 1, if b to the n power is equal to a, then it says b is an nth root of what? A. Okay, so what this would mean then is this. It says, it's kind of saying this, and I'm going to write this down here. So it says, if, I don't know, like 3, or it says b to the nth power is equal to a, it would mean this then. Then it would mean the nth root of a would equal b. And let me just give you an example over here on the side here. All right, guys, up top here, what would 3 squared equal? 9. Okay. Then let me ask you this question. What would the square root, I'll put the 2 out here. If you never see an index out here, you assume 2. But what would the square root of 9 equal? 3 right there. So see how they kind of work in opposite order there like that? You've seen that stuff before. You know that. Okay. We're just going to take things to higher indices as we work through this. So we're going to have higher index and stuff like that. So guys, first thing we need to know is what the heck is an index? Index of a radical right here. Okay. An nth root of a is written as nth root of a, comma, where n is considered the index of the radical. Okay, so if I said something like this, if I said, what's the 7th root of 26? Meaning, what number would I multiply together 7 times to form 26? I would say the index in this right up here, guys, is, what is that value up here, kids? 7. The index is going to be 7 right there. All right. Guys, you've all seen a square root before, right? Like if I write down the square root of 49, you're real quick to tell me, Parson, the answer to that is what? 7. Guys, how many 7s would you have to multiply together to make 49? 2 of them, right? So if you don't see an index right here, the square root of 49 equals a 7. If you don't see an index up there, the assumption is, well, there's really a 2 up there. Okay, so if you don't see an index right up here, what are you going to assume for an index? 2. Okay, now, cube root, what do you think the index is for a cube root? Okay, cube root of, say, let me think of one. How about 64? Anybody know the cube root of 64? In other words, what do you multiply together 4 times, or something, sorry, 3 times? I kind of gave the answer away. Yeah, 4 3 times, right? So in a cube root, the index is what? And I'm going to go back up here to square root. And in a square root, the index will be what? And I think you all know what an exponent is, so let's just write something like this. Let's pick my favorite number, 6 to the, I don't know, 4th power. Okay? Guys, in 6 to the 4th power, which value, 6 or 4, is your exponent? Which one's the power? 4. Okay, 4 is the exponent. Okay. All right, real quick question. Everybody have vocab down right now to start before we get into what we need to understand today? Anybody have any questions so far for me? All right, let's talk about this core concept right here. This is a pretty important one. So, guys, up here, there's a core concept that says the following, okay? There's two different cases. They talk about n being, first of all, what kind of an integer, kids? Even, and we're going to talk about n being an odd integer like this, okay? So here's what I want you to understand here to start, okay? Let's look at this even integer column first, all right? It says if a is less than 0, then there's going to be what? No nth roots. Okay, so the idea here, guys, is this. When I talk about n right here, this n value is some kind of an index. Okay, this n that we're talking about or referring to is an index. Okay, so if the index is ever less than 0, then there's going to be no roots. Okay, so we're going to look at some examples here. Guys, what's it say when a is equal to 0 here? Okay, if a is equal to 0, then there will be one real nth root. So what this is really saying right here, kids, is this. It says the nth root of 0 would equal what value here, kids? 0. Okay, think about this. What number times itself would make 0? 0, okay? How many zeros could I multiply together to form 0? As many as I wanted. That's simply saying the nth root of 0 is always going to be one value, and that one value will be what? Okay. Then, right here, it says, this last part, it says if a is some number bigger than 0, then n, the two real nth roots, it's going to have two of them. One's going to be plus or minus a to the 1 over n. So it might be a plus or minus nth of the square root, or I'm sorry, the nth root of a. So we'll look at some examples right here. But guys, we're always looking to see if our index right here is even or if it is, in this case, going to be what? Odd, all right? Now, same thing over here, guys. If I have an a value that's less than 0, or in other words, it's negative for n or an index that's odd, what does it say we have for solutions? Okay, if a is equal to 0, what's it say for the number of solutions? And if a is greater than 0, what's it say for the number of solutions? So if your index is ever odd, you're always going to have what? Okay. Things get tricky when your index is actually what? Even. You might not have any roots. You might only have one real root, or you might have what? 2. Okay, so let's see if we can piece together this core concept here in terms of some examples. So in example 1, it says finding the nth roots. Okay, so my friends, it says find the indicated real nth root or roots of a. So in this case right here, it says find really, this is really saying find, what's the index in this first example? 5. It's saying find the 5th root of what? Negative 243. So this is really saying, okay, this is really saying the following. This is saying find the 5th root of negative 243. So my friends, first of all, take a look at your index out here. Is that index odd or even? 5 would be odd, wouldn't it? Oh, wait. That's all right. Oh, okay. No worries. Okay. So you all agree that the index is odd. Would you guys agree with that? Okay. How about this a value right down here then? Is this negative or positive? There you go. negative. So we've got an odd index, which puts us in this column, and A is a negative number. It says how many real roots, kids? Okay, so what I might do is this. I might be like, okay, calculator time. Now, I don't know what you guys have for calculators, and you may want to get yours out, whether you're using maybe your phone for a calculator or, guys, Monday when we come back in here, who's going to remind me of this? How many of you guys use a calculator on your phones? I might have you download a good free app that's really good for stuff, okay? But guys, here's how I would do this in my calculator, and I want to see if you guys maybe have this. The first thing I'm going to do is I'm going to type in that A value. So I'm going to type in 243, negative 243. You guys see that right there? Okay, now, what I'm looking for, guys, is a button that would give me the nth root, and I'm not really sure where it's showing up on this. So what I might have to do is look at something different here. That's not going to work. I don't even know if I have a good enough calculator to do this. Scientific. Maybe if I hit second here, we'll see what happens. Okay. Do you guys see this button right here? It looks like, it's like a, okay, they don't have N up here as my index. They actually have what letter is my index in this? Y root X right here, okay? So like the Y root of X right here. You guys see, do you guys have a button like that in your calculator anywhere? I think on iPhones, don't you tip it sideways and it makes it scientific? How many of you guys how many of you guys are iPhone users? 1, 2, 3, 4. Oh, good. We're all on the dark side. Good. All right. Do you guys have that button? So if I hit this Y root of X right here, and then what root do I want, kids? The fifth root, right? What's it kick out for a solution? Okay, it's going to equal negative 3 here. Okay. That makes sense to you? It's pretty simple, isn't it? Okay, let's look at the next example. What root do I want? Or what's the index value to start in the next example? 8. So I want the 8th root of 256. Okay, so let's just talk about this real quickly. Your calculator is only going to kick out one answer. We need to be spot on with some things. First of all, is that index odd or even, friends? It's even, isn't it? Okay, so that puts us right over here. Is that A value down here, 256? Is that greater than 0, less than 0, or equal to 0? That puts us in this row right here, doesn't it? A value greater than 0. What's it say about the number of solutions there for that example then? There's got to be 2, right? Okay. Well, I've got news for you, friends. It says it's either going to be plus or minus that value in the end. Here's the deal, though. Guys, when I type 256 into my calculator, and I go to that nth root of 256, in this case, which root? It only gives me what value? 2. It only gives me 2, but that should really be, based on our rules up here, that should really be plus or minus 2, right? Because the index was even, and this A value underneath was greater than 0 or positive. And think about this, guys. If you take an even number of 2's and multiply them, even number of positive 2's and multiply them, what kind of value are you going to get in the end? Positive or negative? Positive, okay? So you might have to hit no, I think it's that button right there. Okay, no, I think what you need to do in here is just reset all that. Go 256 first. And hit that button that we talked about. And then type 8 in there and hit enter. There you go. Got it now? Okay. But think about this, guys. Negative 2 times negative 2. I've got 2 of them. 2 negatives would be a what? Positive. You having troubles there, D? Oh, are you getting it? Did you type in 256 first, Brady? Okay, and then did you hit that y root of x? And then hit 8? And then hit equal? On board now? Awesome. Thank you, Danson. That was great. But again, if I have an even number of negative numbers to multiply together, it's going to be a what in the end? Back to a positive, won't it? Okay. All right. So are you guys okay with that first page? What questions you have so far? Guys, as far as calculators go, everybody know what keystrokes to make right now to be able to evaluate those? Okay, let's move on. All right. This is where things get kind of fun, my friends. Evaluating expressions with what we call rational exponents, okay? So, my friends, and when it says evaluate each expression right here, what do you notice about your exponent now? They're fractions, right? Okay. So here's how this is going to work for us. All right. Anytime we have a fractional exponent, I'm going to make a little note up here. Okay. Any value a to the, I'm just going to go call it the n divided by m power like that in fraction form. This will equal the following. Okay. This will equal the mth root in parentheses of a all to the nth power. Okay. Guys, take a peek at that. Make sure you've got that written down. All right. And here's how I always try to remember this, kids. Isn't m my denominator up here in this fractional exponent, kids? Okay. M becomes your what right here? What's the word for that right there? M becomes the index, n stays the exponent out here. All right, so the bottom one is the index, the top one stays the exponent. So in this first example that we're about to evaluate, kids, 64 to the 2/3 power, okay, here's how this works. This would really be written as, okay, what would the index be on this first? What will the index be on this first? Okay. So the cube root of 64, and then all to what power, kids? Okay. So the first thing I'm going to do is evaluate the cube root of 64. Guys, when we're looking at cube root of 64, is that index odd or even? So if the index is odd, my friends, guess what? Well, there's only going to be, did you say one solution, Ava? Okay, only going to be one solution. So anybody know this is cube root of 64? Okay, so doesn't this really become, in parentheses, 4 to what power, kids? Which would be what? You guys okay with that? Okay, now, here's what I'm also going to put down here for another note. I'm going to make another note right underneath this one. Call this one rule 1. We'll call this note 2 maybe. All right. If you ever have a to a negative n power, this is equal to 1 over a to the nth power. Okay. I don't traditionally teach this the way math books would tell you, or most math people are going to tell you to do this right. Here's what I want you to think about rule number 2. I want you to think about reciprocals. What was that, Ava? Okay, so if I said what's the reciprocal of 2/3, it would be 3 over 2. Okay, here's what I'm going to tell you about negative exponents, especially negative rational exponents. All right, kids. I kind of want you to treat this as a positive first. Okay, so I'm just going to forget here that this is even a negative exponent here. Okay, here's what we're going to do. We're going to treat this as the 4th root of 16 all to what power first, kids? Okay, it'll be negative 5. I'm going to put a 5 up here first. Okay. Now, you kind of have to be careful on this. Kids, the index inside of parentheses, is that positive or negative? It's positive, isn't it? The index in there is positive. Is that index even or odd? Even. Okay. So my index is even. How about the A value under the root? Greater than 0, which means how many solutions? Actually, this one would mean 2 solutions. So here's what we're going to do. We're going to do the fourth root of 16. Anybody happen to know the fourth root of 16? If you weren't sure, we could punch it in. So let's just go 16 nth root of, what was the root up there for, guys? Okay, we get a 2. And we're like, okay, calculator says 2, but is 2 the only possibility here? No, it could also be a -2 because our index was even. And the A value is greater than 0. Okay, now we have to think about this. Guys, this is like 2 to the 5th or -2 to the 5th. So help me with the math. 2 times 2 times the third 2. 8 times the fourth 2 times the fifth 2. 32, right? Think about this. -2 times -2 is +4. Third -2 would make -8 times another -2. We are back to a +16. -32. Okay, now, guys, here's the big catch. We've got to be careful on this. That exponent that we started with originally was positive or negative? Negative. So since that was negative, then we've got an answer of 32, but since that exponent was negative, our final solution in this either becomes 1/32, because that's the reciprocal of 32, isn't it? Or what other value? Okay, this here, my friends, would be your 2 possible solutions, plus or minus 1/32 there. Okay, plus or minus 1/32. Get a different color around that. Okay. I think that's a pretty good place to stop today. Okay, you guys okay with that? All right, let me